Let's work with the sum and difference identities. For example, let's find cosine of alpha minus beta if sine of alpha is negative 5/13, cosine of beta is 12/13, alpha is in quadrant 3, and beta is in quadrant 4. Well, let's recall the difference formula for cosine. We have cosine of alpha minus beta is equal to cosine of alpha, cosine of beta, and then plus sine of alpha times sine of beta. Remember, with the cosine identities, if this is a minus, then this is a plus. Now we're given that sine of alpha is negative 5/13. Therefore, we know this already. And we're also given that cosine of beta is 12/13, which means we know this as well. So it remains to find cosine of alpha and sine of beta. Now there are different approaches here. We could use identities, for example, but let's use triangles instead. Now we're given that sine of alpha is equal to negative 5/13, and moreover, alpha is in quadrant 3, which means we can draw the following triangle. Because remember, sine of alpha is y divided by r. And notice we're putting the negative with the y because y's are negative in quadrant 3, and r is always positive. And then we can use the Pythagorean theorem to find x here. Namely, x squared plus y squared is equal to r squared, or x squared plus negative 5 squared is equal to 13 squared, or x squared plus 25 is equal to 169, and therefore x squared is equal to 144, which means x is plus or minus the square root of 144, which is equal to plus or minus 12. Now remember that x's are negative in quadrant 3, which means we're going to choose the negative possibility down here. That is, x is equal to negative 12. Now looking back over here on the left, remember that we need to know what cosine of alpha is. And remember that cosine of alpha is equal to x divided by r, which is equal to negative 12 divided by 13. All right, so it still remains to find this sine of beta here. So let's do the same thing. We're given that cosine of beta is equal to 12/13, and beta is in quadrant 4. So we can draw the following triangle, remembering here that cosine is the x divided by the r. So our x is 12 and our r is 13. And again, we can use the Pythagorean theorem to help us find y. Namely, x squared plus y squared is equal to r squared, or 12 squared plus y squared is equal to 13 squared, or 144 plus y squared is equal to 169, which means y squared is equal to 169 minus 144, which is 25. And therefore, y is equal to plus or minus the square root of 25, which is equal to plus or minus 5. Now, since y's are negative in quadrant 4, we're going to choose the negative down here. That is, y is equal to negative 5. Now remember, we need to find sine of beta. So let's compute that over here on the left. Sine of beta is equal to y divided by r, which is equal to this negative 5 divided by 13. Okay, and now we have all the pieces to compute cosine of alpha minus beta. In other words, looking up here on the right, we found cosine of alpha, so we know that. We're given cosine of beta, as well as sine of alpha. And looking down here on the left, we just found sine of beta. And therefore, cosine of alpha minus beta is equal to cosine of alpha, which is negative 12 over 13, times cosine of beta, which is 12 over 13, plus sine of alpha, which is negative 5 over 13, times sine of beta, which is negative 5 over 13, which is equal to negative 144 divided by 169, plus 25 divided by 169, which is equal to negative 119 divided by 169, which would be our answer. And this is an example of how we work with the sum and difference identities. Thank you, and we'll see you next time.